As David said, detection and treatment of organics and sulfates. To start off with the 2014 specs, and then I'll lead on after that with the organics and sulfates. So the specs were written and are updated, and in the lime treatment, fly ash, and cement, language has been added to include sampling and testing for organics and sulfates. Specifically, here's the language. It's referring to two test procedures. And I'm going to get into further details about these two test procedures later on, but so essentially we have a procedure for a colorimetric method, and then we have a new procedure on what they call ultraviolet visible spectroscopy, and that's too many words, so we kind of put that nice acronym. So moving on, language was also added with the borrowed material. So the thing you don't want is taking material that has the sulfates and organics and spreading them around on a project that does not. You don't want to create the problem. These are the two slides that I had for the specifications, again, requiring the sampling and testing, and then the borrowed material. Okay, start off with the organics. So what are the general characteristics? Well, as you can see from this picture, brown, dark in color. It has a high pI, high moisture content, mostly found in poorly drained soils. And from this picture here, it could be anywhere from 0 to 5 feet. Another good way to, well, a way not to jump ahead to detect the organic matter, one way is to look at soil survey maps. And they generally have a % organic matter that give you a general idea of the area to where you can go sample and determine the content. Okay, so just a brief slide on why the detrimental effects. So essentially, the organic matter or the organic component that we're focusing on is called humic acid. What we want to do is detect this because this consumes the calcium. Without the calcium, you're not going to get the treatment that's needed. So generally, these soils are high pI, and they're treated with lime. And you need that calcium for the reaction to occur. And I have two pictures here. Here's a scanning electron microscope picture. One is just a clay particle, not treated, and the next one's treated. So essentially, you add the calcium, you drive up the pH, you get the cation exchange and flocculation, what have you, to get this kind of a structure here. So when you look at this wave here, this material here is prone to swelling, and that's something you don't want. Not as moisture, maybe prone to moisture susceptibility. But this here, when you get this flocculated type structure, this is where you get the good working platform and eventually the long-term gain in strength. The pozzolanic reaction, if they call it. Just wanted to get into that briefly. Okay, so the laboratory methods that we have. There are 3 methods. One's the loss on ignition, essentially using an ignition oven. The method that's now referenced in some of our specs, text 408. And then the third one is the new procedure that is required in the specs. So I'll start off with the ignition oven. It's a quick, fast, relatively inexpensive because everybody has an ignition oven. It's essentially dry combustion above 750 degrees. It's fast. The bad part is the results may be inflated because when you're at that high, it's not going to differentiate between the organic and the inorganic. It's just lumping it together, burning off all the organic. And then additionally, you may be burning off some minerals, and so your results may be inflated. And also, you're not capturing the humic acid, which is the detrimental part of the organic matter. This procedure is pretty much a color test. You're mixing your sample with a sodium hydroxide, shake it up, wait, and then you have a known standard color chart here. Anything below that has organic. Unfortunately, that is a qualitative test. It's just tell you presence. It will not give you the content. And how the specs are written, there's no more than 1%. So Yeah, and that's not quantitative. So moving on, we have a new test method that this method was proposed or evaluated and researched by TTI, and it's called the UV-VIS. And like I said earlier, that's an acronym short for using an ultraviolet visible technology, ultraviolet visible spectroscopy, that technology. So with that, there are two models. There's a benchtop model that can be used, and then there's a portable model. The benchtop model, this is something that we have in the rigid pavement section. They use this for their testing, and so what we could do is we use one aspect of it. This is not something we recommend for people to buy to measure this test. If someone needs to check this organic content, we recommend this portable unit here, and I have a few other pictures going on here. So in this picture here, essentially you have a halogen light source, a spectrometer, and a fiber optic cable. That's the guts of this thing to measure that humic acid component. This is it laid out. This is a test that can be run in the field, and when I say field, I mean area lab, not on your tailgate in the back of your truck or at the actual road. We generally just run it in the lab. So this is the picture of the benchtop model. So essentially it's emitting a light source and measuring an absorbance value. And the research has shown that at a wavelength of 300 nanometers, it can detect the humic acid component. That's the component. Again, that's what we're looking for. The procedure is a little involved. You're mixing 3 different type of chemicals. You're testing standards. You're testing 6 standard samples. It's just a little more involved when you're looking at the ignition oven and also at the color standard type tests. But again, that's the test that will detect the humic acid. So advantages, it's looking at that harmful component of the organic matter. The challenges, it is more involved. Takes a little more time to become proficient, and the testing equipment may be a little more sophisticated, but all that can be overcome. So what do we have for treatment? Anything below, at or below 1% has been, you can use standard practices. It should be fine. Anything above that is a concern. Right now, we've looked at primarily Lyme treatment, and because of the high PIs. Generally, you're dealing with 20 or more, probably higher than that. So most of the work we've done, research that's been done, has mostly focused on Lyme, but it all starts with a mix design, and we have 3 procedures that can be used, either for soil cement, soil lime, or fly ash. But what we're looking at is essentially a ratio. So the recommendation is if you have organic specifically measured with the UV-VIS device, is to try to have a ratio of the organic matter to lime content. Now the lime content here is measured by looking at it's part 3 of our procedure, and it's what they call Eads and Grimm, but essentially you're looking at the lime content to get to 12.4 pH. You want to make sure you get that reaction to eventually get your strength gain. So you take the organic matter percent from the UV-VIS, divide that by that lime percent, less than 0.5. 0.5 or less is a good recommended treatment. And of course, verifying the strength. Something else that was evaluated was adding calcium chloride. It was evaluated in the lab, looked promising, but not validated in the field. That's all I have for organics. So I didn't know if anyone has any other treatment or experience with that. Just kind of curious if anyone does anything different. Just okay. All right, moving on to sulfates. So this is probably more of interest. It's more known. So what are sulfates? Well, they're mineral salts. They contain sulfur. As you can see from the picture, it's a diamond-like looking. It's soft, can be scratched with your fingernail, and it's located. It can be located in any climate, any soil, any depth. They could be different grain sizes, as you can see here, from look powdery to all the way to the coarse. And then it could be just scattered or in veins. Detection methods, well, first is visual. If you can see it, then that's obviously known. If not, we have field tests. Conductivity is a good indicator, and conductivity is a measurement of salinity. However, that conductivity value doesn't differentiate the sulfate value of that salt. So that salt is not, you don't know, it's not completely sulfate. So that needs to be followed up with this procedure here, and I'm going to talk about that in a little more detail later. That's our test using a colorimeter. Another good source to detect or give you an indication are soil survey maps. And it's a good starting point for sulfates, gypsum. Oh, and I didn't mention that in the previous slide, typically seen as gypsum throughout here, Texas. So I'll start with, these are the field tests, conductivity. This is a fast test. This test here could be at the site on the tailgate. You just have a conductivity meter, a beaker, or what have you. It could be done pretty quickly. Air dry your sample if you have to. You can just put it on the hood of your truck. It'll dry quickly, or what have you. And it's relatively inexpensive. The other method, or another good tool that we could use, is what they call the Veris soil mapping system. And this is not used too much, so I just want to put it out there. It's a tool that we have. It's something that is available. If you, even in an area you think you have sulfates or see it, call us. We'll come out there. And just some brief information here. It is a screening tool. It could measure your sulfate, conductivity again. I didn't mention that. It does measure conductivity like the other previous test. So it's a screening tool. It can be used anytime, whether it's at the, as you can see here, anytime during construction. And it's a rapid test. You can cover a large area in a relatively short period of time. So just a little detail here. You have these discs, essentially tills. They're equipped with electrodes, and it'll measure a current that's passed on, and it can measure a conductivity value. And this is just a little chart showing above 100, that's with salinity. Those are the high values, but again, screening tool to where it needs to be run with a colorimeter test to verify that the sulfate portion of that salt is sulfates. And what's really good about this tool is that you can use ArcGIS to develop a map. So the data that's collected from the test could then be plotted, and then you could target certain, like this red here, it's pretty high, or anything above 100 may warrant some sampling, and then you'd know the locations to go. All right, so those are the two field detection methods. You have the essentially measure conductivity. And moving on, this is the test to give you a true indication of the amount of sulfates out there. It'll give you a concentration amount of parts per million. So it's what they call a turbidimetric technique, essentially using a colorimeter to determine a cloudiness of a certain of your solution, of your soil solution filtrate. Again, uses a colorimeter. There are sulfate tablets, and let me move on here because this is more probably a better illustration here, the colorimeter, the tablets. But look at this here, and this, again, illustration here. This is the soil solution after it's been soaked and filtered, and then after the tablet's been crushed. And actually, it's not run this way. The tablet is crushed in here, but just for illustration, there's that cloudiness, and then it'll measure a concentration of sulfates. There are two parts of the procedure. One's a field test, one's a lab test. Now, it is a field test, but the intent, again, is not like the conductivity test. You can't go in the back of your truck and start running it. It's more like an area lab type test. And there are two different purposes. One's mostly for QC, and then one's for pre-design or your investigation before maybe letting plans or letting or what have you. Okay, so what are the why are we detrimental effects? Why? Well, essentially you have the sulfate-induced heave, you have the formation of the ettringite. When you have these high sulfates, calcium stabilizer, and then with the water, and very expansive, possibly more twice its original size. It can occur anytime during construction. Look at these three pictures here. Could have rained the night before. A year later, somehow moisture migrated there into the layer, and then you get your heaving, and then could occur several years later. Doesn't matter. Hot mix concrete. Just known is that it is costly to repair. Not costly to mitigate, but the repair is costly because you really can't fix it. You can make the road smoother, but you can't fix the problem thereafter. Okay, so our guide, or yes, I'll get further down about the guide, but we do have different levels of treatment up to 3,000 or 3,000 or less, then a range in between 3,000 and 7,000, and then anything more than 7,000. So if treated, you can see there are smooth, good performing pavements that can be achieved in long-term performance. Okay, so I'll start off with the easy one, less than 3,000, not a problem. You could use your standard practices, construction practices, mixed design practices, that's not a problem. So once you get in between 3,000 to 7,000, this is where you have a lot of options. You can look at your mix design and your construction techniques. Of course, they need to be hand in hand. And most of the problems are associated with higher PIs, so it focuses around lime treatment. And our mix design procedure is 121, but that needs to be used in combination of the colorimeter, the procedure that I talked previously about the colorimeter. So you can use the 145 to determine a period where you can drive the sulfate content below 3,000. So essentially, adding moisture and running the test every day, you can see how many days it takes to drive down that sulfate content. Because you're essentially forming the mineral ettringite in there, and then you want to determine what's the calcium that's available, and then you can determine how much sulfates you have left. I don't know if that made. So with that in combination of 121, where you get your lime content and your strength, essentially you can determine a mellowing period. So when going to construction, recommendations are apply that lime in one treatment, thorough mixing with adequate moisture, because you want that moisture there. You want to form the mineral, the ettringite, and light compaction to seal. You don't want that water to evaporate. You want to keep the water in there for that mellowing time, and again, the mellowing time is determined with the colorimeter test. And why mellowing? Well, you want that ettringite to form. And then more importantly, well, as importantly, you need to keep the moisture in there, because that's, in addition to the calcium, it needs that water. Specification, this is what's written in the 2014 specification, essentially requiring a mellowing time of a minimum of 7 days. And anything not of concern, 3,000 or less, 1 to 4 days. Going on up to level 3, the high risk, there aren't many treatment options. Essentially remove and replace, which, that costly. There may be possibly blending in some lower or non-plastic materials such as sand and aggregate. But something that we are looking at, and I'm going to get further into it, is using different additives or a combination of different additives. So this is a project in the Paris district on US 82, and what they have done is that they've used a combination of lime and fly ash. So TTI did some extensive lab work. They looked at those two procedures, the 121 to soil lime, and they looked at the colorimeter test to determine a mellowing period. And what they did was on the first day, treat it with 6%, let it mellow, and on the 8th day, applied to 3% fly ash. And then a 10th day is when they did their final compaction. And I believe that was about a couple of years ago. It's too early to tell. It's just not enough time. So I believe right now, I think the University of Texas in Arlington are monitoring that site, and so far, so good. This is what it looks like. As you can see here, plenty sulfates, very high range. So the Verus was used, and on this end here, the west end had the extremely high conductivity, and then that was, the colorimeter was performed, and then these high sulfate contents were measured. Did have a high PI, high moisture. So this is how the Verus was used as a tool, as a screening tool. It covered a large area in a rapid period of time. They knew which areas to sample, and it was very useful. What was part of this is part of the laboratory testing, very extensive, getting lime content, knowing the number of days for the mellowing, and then a 3D swell test. This is not very common. It's, again, another test that TTI developed and looked at. So essentially, swell of less than 6% correlates to a PVR of less than 1 inch. And go on, and this is what it looks like. So it's using a super paved gyratory compactor to mold the sample in one lift, and that is a 4 by 4.5 at the optimum moisture and molded to density. Conditioned for 28 days, and then the weight, volume, and length are measured daily. A very good test for swell. Here's just a little more detail, measuring weight, volume, and length. And this is a plot that we can look at. You have a 3-day drying, and then here's that heaving time. And that's what we need to know, and then ultimately when it levels off of that percent swell. So when they did this mitigation in the lab, they found that after, like I said earlier, I believe 25 days, they were getting it down to 6%, and it's very useful, very informative, very helpful. Okay, with that said, there are guidelines out there, and if you, I just put a link up there, and I know a lot of times these links are so long, but I know at the end these presentations are, I believe, available. But just if you need that, TxDOT has that on their website. You can navigate and find it, or if not, call me. This is an old, well, I'm sorry, we are updating this guideline, so it's going to look a little different than this. We're going to put it in a new template, the TxDOT template, and so on. So with that said, and there's a map of where the high sulfate concentrations are known so far. There's a nice picture of a vein right there. Is that gypsum? And then there's another blow up. That's all. Yes, sir.
I'm kind of confused. Is this just a design, or is it something you're finding in construction?
Well, you can possibly see it. Oh, I'm sorry. So the question is this something you see during construction, or do you find it in design? Mostly it's, first, you may see it. So, for example, you're out here, you're seeing it before the project's probably designed or let. And then you may then do some field testing to see what could be done to mitigate the swell. So then there are construction techniques that can be applied to form that ettringite during that mellowing time, to where you don't have that sulfate heave during in-service. Now you also need the design, you need the testing to know how much you have. So it can be it's a combination of all three. Does that answer?
Yeah, I'm just wondering, from a design perspective, we're gonna have a geotech. The geotech come back with a recommendation. And then we're gonna have to construct it, right? So, but what I see right now is some construction time methods versus something predetermined, I mean, for detection.
Yeah, for your pre-design work, hopefully, if you know you're in an area that may have high sulfates, by looking at a soil survey map or by previous experience, it probably should recommend that the colorimeter tests. And then that will dictate what you would need thereafter. Any other questions? Tom?
I think you've got a map coming up of Texas, one of your slides, towards the end, that map there. And if you're in that green area that's highlighted there, that's where a lot of the problems have been. But those other yellow areas are, areas that are...
Yeah, a concern, and that's where the field, the conductivity meter or the Verus, especially the Verus. The Verus is easy, fast. We can be there in a day or two, depending, and we can cover a large area in a very short period of time. So that's pretty much advocated. If you look at a soil survey map and you think there is potential, give us a call. We'll come out there with the Verus, and it can easily determine sampling locations if the conductivity values are high.